Hi everyone. Today I want to talk to you about the electromagnetic spectrum. That includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves for AM radio, microwaves for cooking, infrared for night vision, visible light, the light we can see, the sun. Too much ultraviolet rays can cause sunburn and damage the skin. Can also damage your eyes. So get a good pair of UV sunglasses. X-rays, doctors use X-rays to see bones and teeth. And gamma rays. Gamma rays are used in medicine for MRI. I want to focus on visible light. Why? Because we can see it. It's sunlight. There are tools we can use to help us study light. We can use a prism. It bends the light and separates the different wavelengths, the colors, into a rainbow. Raindrops act as our natural prisms to make rainbows. We can use diffraction grating. It also bends and separates the different light waves. This comes in a 6 by 12 inch sheet. I cut them into 2 by 2 squares for student use. This style of diffraction grating comes mounted on a slide. It is important to notice each light source has a different spectrum with different lines and thicknesses. In fact, each light source produces its own spectrum or fingerprint that identifies its contents. Scientists can tell what the burning gas is made of using a spectroscope. That brings me to show you another tool that shows the different spectrums of different gases. This is called the Spectrum Power Supply Carousel. I have 7 different tubes of gases that will produce different spectrums. There are hydrogen, helium, oxygen, CO2, argon, neon, and nitrogen. CO2. Helium. Hydrogen. Argon. Nitrogen. Neon. The next gas we have is nitrogen. Nitrogen is a little easier to see, but we can see it's different and different lines. The lines and separation of the black line spectrum give us the fingerprint for nitrogen. And the last gas we have is neon. There we see neon has a unique fingerprint. And those lines are special too, because those lines can shift, meaning move together to the left, which would be a red line shift, or to the right, which would be considered a blue line shift. And when those lines shift, we can tell if the object or star or light is coming to us or going away from us. That's how we tell the movement of stars, by a red shift or a blue shift. So there you have 6 different gases of the electromagnetic spectrum. They each have a unique fingerprint, so we can look at any element and just simply rotate it to the different gases. The electromagnetic spectrum is the sun.